This is the tech team for Ericsson Robotics, which is comprised of Atish Bharadwaj, Sanjana Kishore, Tejas Ram, and Veda Kutagla. Our job is to program the robot using Simulink, which is a product of MATLAB. Simulink is a graphical programming environment that allows you to drag and drop blocks. It roughly translates to C/C++.
This is our drive system. Our drive system works based on certain criteria that is to be met by our joystick's X and Y axes. For example, in order to go forward, the Y-axis of the joystick needs to be greater than 0, and the X-axis of the joystick needs to be around 0. Then, the speed of the motors will be equal to the Y-axis of the joystick. If the criterion fails to be met, then the motors will cease to spin forward. Our simple but functional program allows the driver to easily navigate through the field and perform the required tasks. Our program also adds depth to the movement of the robot. In other words, the robot will move at the angle and force at which the joystick is pushed.
The left joystick controls the arm. The arm will move in the direction the joystick is pushed, just like the driving system. This helps us perform tasks for this year's competition.
When the 5-up button is pressed, then the motor that controls the claw will spin forward, thereby opening the claw. Similarly, when it is released, the claw will close. This allows the robot to effortlessly pick up an object, such as the mannequin.
The 6 up and 6 down buttons control the pin release system. The pins hold our catapult down. When we press both buttons down, the pin will be released, launching the items in the catapult by a bungee cord pulling one end of the catapult, and the other end will fling forward.
This is the pin release subsystem. It checks whether both buttons are pressed to release the pin.
In conclusion, this is how our program for our robot functions. Thanks for viewing our Simulink design video for the Best 2017 competition. Make sure to support Ericsson Middle School this year.